Today we are going to talk about factoring trinomials. By the end of this video, you should be able to factor a quadratic, solve a quadratic equation by factoring, and determine a factored form of a polynomial expression from the x-intercepts of the graph of its corresponding function. First, as we mentioned in the last video, you need to make sure that you check and see if you can factor out a GCF before you do anything else on a factoring problem. For the first problem, we are given the trinomial 5x squared minus 13x plus 6. 5, negative 13, and 6 do not have any common factors other than 1, so there's no GCF to worry about in this problem. Since this quadratic is written in standard form, let's note that 5 is A, negative 13 is B, and 6 is C. When factoring a trinomial, the first thing we need to do is find two numbers that multiply to A times C and add to B. So here, A times C is going to be 5 times 6, which is 30. B is negative 13. So we need to think about multiples of 30 that add up to negative 13. If you need to, you can write out a list of factors, or later in the video, I'll show you how to use the calculator to help you find those numbers. But for this example, we need to think about numbers that multiply to 30, and then find two that add up to negative 13. So in this case, that would be negative 3 and negative 10. Then, our second step is to split the middle term. So, in my original equation, I had 5x squared minus 13x plus 6. I am going to split up that negative 13x using the two numbers that we found earlier. So I'm going to split it into negative 3x and negative 10x. If I combined like terms, I would still end up with what I started with, so I haven't changed the problem, I've just changed how it looks. Then the third step is to factor by grouping. So, as we learned last class, that means that I'm going to put parentheses around the first two terms and parentheses around the second two terms. Then I'm going to factor the GCF out of each parenthesis. For the first parenthesis, that's x, and I'm left with 5x minus 3. For the second parenthesis, the GCF is negative 2, and I'm left with 5x minus 3. Then I need to see what these two terms have in common. They both have a 5x minus 3, so my GCF is 5x minus 3. And when I factor that out, I'm left with x minus 2. As we mentioned in the last video, we can always check our work. So if I take 5x minus 3 and x minus 2 and multiply them back together by double distributing, I get 5x squared minus 10x minus 3x plus 6. Then I combine like terms, and I get the quadratic that I started with. So our factors are 5x minus 3 and x minus 2. Let's look at the next problem. We have x squared minus 13xy minus 30y squared. So a is 1 and c is negative 30. When I multiply these together, I get negative 30, and I need two numbers that multiply to negative 30 and add up to negative 13. So that would be negative 15 and 2. Then I'm going to split up the middle term. So I'm going to split it into negative 15xy and positive 2xy. And I'm going to factor by grouping. The GCF of the first set of parentheses is just x, and I'm left with x minus 15y. The GCF of the second set of parentheses is 2y. When I factor that out, I'm left with x minus 15y. Then, if I look at these two terms, the GCF is x minus 15y, and I'm left with x plus 2y. So this is my final answer. Again, you can multiply it back together to check, but I'm not going to do that right now. For number 3, we need to double check and see if there's a GCF in this quadratic, which there is. I can divide all of these numbers by 2, so I'm going to factor out a 2. Then, with the part in the parentheses, I continue with the process we just learned. So a is 12, c is 2, so a times c is 24. I need to find two numbers that multiply to 24 and add up to 11, which will be 8 and 3. Then I can split up the middle term into 8x and 3x, and then factor by grouping. The GCF of the first set of parentheses is 4x. And after I factor that out, I'm left with 3x plus 2. The second set of parentheses does not have anything in common except 1, so I'm going to say that the GCF is 1. Then when I look to see what these two terms have in common, they both have a 3x plus 2. And then after I factor that out, I'm left with 4x plus 1. And don't forget to bring down the original GCF of 2. So those are my factors for problem number 3. Now let's take a look at solving by factoring. Problem number 4 is already factored for us. To solve, I'm going to take the first factor and set it equal to 0, and then take the second factor and set it equal to 0. This gives me two equations to solve. The reason we do this is because of the zero product property. The zero product property says that when a product is equal to 0, one or both of the numbers being multiplied must equal 0. So if I solve this first equation, I get x equals negative 2. If I solve the second equation, I get 3x equals 1, and then x equals 1/3. So these are my two solutions. With problem number 5, we still need to factor because it's not already factored for us. And in addition to factoring, we need to make sure it is set equal to 0 first. So if I subtract 15 from both sides, I end up with 12x squared minus 8x minus 15 equals 0. And you need to make sure that the quadratic is written in standard form, with the x squared term being first, followed by the x term, and then the constant being last. So if I check for a GCF, there is nothing that can go into 12, 8, and 15 other than 1. So we start by multiplying a times c, which is 12 times negative 15, which gives us negative 180. Now, 180 is a rather large number. So you might have trouble figuring out what multiplies to 180 and adds up to negative 8. If you got stuck, here's a trick. Go to your calculator. We're trying to multiply to negative 180. So if we go to y equals, and then type negative 180 divided by x, and then go to the table, which is second graph. This can be very helpful for trying to find numbers that multiply to negative 180 and add up to negative 8. If we look at the table, each row multiplies to give you 180, or negative 180. So you just need to look at each row that does not contain a decimal and find the two numbers that add up to negative 8. So if we look through here, 5 plus negative 36 does not equal negative 8. 6 plus negative 30 does not equal negative 8. Skip the decimals. 9 plus negative 20 does not equal negative 8. 10 plus negative 18 does. So those are the two numbers that I want to use. So my two numbers are negative 18 and 10. So now I'm going to split up the middle term into negative 18x and positive 10x. Then I'm going to factor by grouping. The GCF of the first set of parentheses is 6x. When I factor out a 6x, I'm left with 2x minus 3. When I factor the GCF out of the second set of parentheses, the GCF is 5. And I'm left with 2x minus 3. I then check the two terms to see what they have in common, which is 2x minus 3. When I take that out, I'm left with 6x plus 5. So I have now factored this trinomial. To solve it, I need to take the first factor, set it equal to 0, and solve. And then take the second factor, set it equal to 0, and then solve. So 3/2 and negative 5/6 are my two solutions. On problem number 6, we have x squared minus 5x equals 36. We need to make sure we set it equal to 0 first. So I'm going to subtract 36 from both sides. Then check and see if there's a GCF, which there is not. So I need to multiply a times c, which gives me negative 36. Two numbers that multiply to negative 36 and add up to negative 5 are negative 9 and 4. So I'm going to split up the middle term into negative 9x and 4x, and then factor by grouping. The GCF of the first set of parentheses is x. When I take that out, I'm left with x minus 9. The GCF of the second set of parentheses is 4. And when I take that out, I'm left with x minus 9. Then I need to check each term, see what they have in common. They both have an x minus 9. And when I take that out, I'm left with x plus 4. To solve, I need to set each factor equal to 0 and solve. So I get x equals 9 and x equals negative 4. Lastly, we have a graph. Part A says to state the zeros. Remember that zeros is another word for x-intercept. So if I look here, my x-intercepts are at x equals negative 1 and x equals 5. To state the apparent factors, I'm going to work backwards. If I know that the answer is x equals negative 1, if I add 1 to both sides and set it equal to 0, that tells me that x plus 1 will be one of my factors. If I do the same to the other 0, x equals 5, subtract 5 from both sides to set it equal to 0, then I know that my factors are x plus 1 and x minus 5. As we learned when we wrote the equations of graphs, that is not necessarily the equation for this particular graph, but those are the factors for the equation that is represented by this graph.